Hold on a second. Don't start yet.
Mom,
Hold on.
yeah.
Is she here to? Yeah, just leave it there because if they're not here, then I'll be able to put their name on it.
Did you give her some?
Who's that?
Jalen.
Oh, Jalen. Yeah. Here.
Hey, what desk are you sitting at today?
The regular one.
That one? Yeah. He brought us. I know.
I see that. That's
I
pretty
talked to him
awesome.
about this last week.
All right, so we ready? Anybody need an extra second?
Me.
All right, we're starting in
5, 4, give you 2 extra seconds. 3,
2. Oh, wait, hold on. 1.5. 1 1/4. Wrong thing. 1 4. 1 8. Here we go. Go. All right, here we go. So you should have your notes. Did anybody not get the notes that were on your desk or that they'll hand it out? Righty. So we're going to review first what you did in Algebra 1. And then in a couple of days, we'll take it further and we'll expand on it to do Algebra 2 stuff, okay? So we're going to learn the first 3 learning targets today. We're going to fly to kind of get caught up a little bit from the 2 days we were out. We've got to get caught up between now and December. So what's the very first thing we're going to learn how to do? By graphing. And when we graph something, what letter do we want to be solved when we graph something?
For A.
Y.
For Y. Yep. When we graph something, we want to be solved for Y. All right, so then we're going to learn what next? By substitution, right? Is this bringing some memories back from Algebra 1? We kind of remember this stuff. At least we remember doing it. Okay. I'll do better, child. You know you did. And the third one, what's the third one? Elimination, okay? So here we go. Somebody let Jalen in real quick.
I think this is my favorite section.
Oh, I know. This in chapter 4. These are 2 of my favorite ones. And Trig. These are my favorite ones. I love Trig. All right. So, I know most of you in here are visual. So we're going to take this whole little sentence paragraph thingamabobber here, and we're going to draw some pictures at the top of your notes to make things easier for you. Are y'all okay with doing that? Mm-hmm. All right. 3. 2, 1. Here we go. All right. So, what is the title of the notes today?
Solving system of equations.
So keep that little nugget in your head. And a blank is 2 or more equations with the same variable.
A system of equations.
There you go. So they're equations. They're not inequalities. So we don't have to worry about dotted lines or solid lines. We don't have to worry about where it shades. We're just going to graph and be done, okay? All right, so there are 3 different types of graphs. And a system is called consistent if it has at least one solution. So let's draw a picture about what that looks like. One solution. Why do they pick that name? Look at that graph. Because it crosses at one point. Very good. It crosses at one point. So this guy is called consistent. Yes, this one type. There's 3 different types. So let's see. A system is called consistent if it has at least one solution, and it's called inconsistent if it has no solutions. So one solution is where it crosses at one point. No solution would look like what? Parallel lines. Beautiful. All right, leave you some space because we're going to put a graph in the middle here. So we're going to do our parallel lines over here. And this guy was called inconsistent. Move that over a little bit. There we go. All right, so if it's consistent, do you remember when we did functions? And if you called it a function, you called it one-to-one or onto, right? But if it was not a function, we were done with it. We didn't call it anything else. So it's the same thing here. If it's consistent, then you can call it something else. But if it's inconsistent, it's done. So if it's consistent, then it can be called either independent or dependent. Very good. So if it has exactly one solution, like this first graph we drew, then it is called independent. So let's go to our little graph right here. So this is called consistent and independent.
Miss Blackman,
Yes, ma'am.
if I meet people in class,
Yes, ma'am.
did she go to the 5th period today?
I'm sure she probably did. Did you go have it? Yes, ma'am, she did.
Okay, they marked her missing.
She said she went, and she's a pretty good kid. I trust her.
Okay, alrighty,
Okay.
thank you.
I trust you. I'm sure you were there. It's probably just the person above you or below you and the I now was missing, and they probably just clicked the wrong thing. I've done that before. All right, so where are we at? If it has one, then it is independent. And if it was infinitely many solutions. Ooh, what in the world does that mean? Infinite. What you got?
It's the same.
Look at you go. It's the same line. Perfect.
I know I'm feeling back.
So that is called, if it's the same line, it's called consistent and dependent. Just let's fill that in our blank over here. So let me give you an example. Like 2x plus y equals, I don't know, give me a number.
5.
5. Or y equals negative 2x plus 5. A system is 2 or more equations, right? Right now we're going to review from algebra, so we're only going to have 2. Are those 2 the same line?
Yes.
Why?
Because once you subtract the 2y,
The 2x, yeah?
2x plus 5.
There you go. You get the same thing, right? All right. So let's go ahead and look at this. Number 1. What? If you were to
Of course
subtract.
they're the same, Mom. You have the same.
No, but I'm giving you that.
So that would be consistent.
That would be consistent and dependent. Yes, ma'am.
Oh, I don't like this stuff.
Oh, gosh.
I remember this.
All right. So, y'all know how I am. I'm like real organized and like my stuff real nice and pretty. So I'm going to do this in 2 different colors. It's up to you. However you learn. You don't follow what I do. You do what's best for you. Okay? You do you. And whatever you need to do to learn. but I have found that a lot of y'all learn kind of like I do. So, anyway, or not all of us, but a lot of you. What color what? Yeah, anything but purple. Green time. Alright, we ready? How would I, if I'm graphing, what do I need to do? Which means I need to solve it for y. So there are 3 different ways we're going to do these, guys. So you might want to make yourself a note somewhere that when you're graphing, you want it solved for y, okay? So we're going to do that with each one. With substitution, I'm going to give you a pointer. And with elimination, I'm going to give you a pointer. So your pointer for graphing, solve for y. Yep. Alright, so we would solve for y by subtracting the x. So we would have 2y is equal to negative x plus 6. And then we would divide by 2 for each one. So, perfect. Alright, then we're going to graph it. 1, 2, 3. Come on, let's focus. We got stuff to do. We're going to go down 1 and right 2. Now look, you want to go as big as you possibly can so you can make sure you see where they graph. Where are you going?
Hold up, you lost me when the dude walked in.
Oh, you just need to hand that to him? Oh, okay, gotcha. Bye. Bye, Bobby. Alright, so since it says y equals, then that means that you don't have to worry about what kind of line it is, right? It's just going to be a straight line. Pretend like that went through all the dots. Pretend.
Me too.
We just graph. All we do is graph, okay? Alright, let's do the other one. 2x plus y equals 9. I need to solve it for y. So I'm going to subtract the 2x. I think this graph only has 8. I think I just did this earlier. Yep. So we're going to go up. We have to go 1 off the graph. Alright, so we're going to go down 2 and right 1. And when you do that a couple of times, what do you notice? It crosses.
Wait, no, I was so if they're like doing the math.
Yay.
Slow it down.
We really can't slow it down, so you need to hustle.
Will they ever cross in like the middle rather than on a specific point?
They can, but I'm not going to be that mean.
Okay.
Now, I'll give you decimals on substitution and elimination, but not on graphing, because then you're like, where you don't really know where it crosses, and that's, yeah.
Hey, why did you start way yonder?
Because we didn't have a 9.
Because you have 8, so just go one more. Alright, so since they cross, look up there at your little cheat sheet we made at the top of your notes. There's 3 graphs. Very good. Alright, now, on the ACT, they like to put these on the ACT, okay? And normally what they ask you is what is the point of solution, or what is the solution, or something like that. The solution is one solution at the point that it crosses. What point is that? 4, 1. That's normally what your answer would be on the ACT, okay? And that's it. Let's move to the next one. Alright, on the next one, you're graphing. So if you're graphing, what needs to happen?
Solve for y.
Solve for y. There you go. So y minus x equals 5 means I would add x over. And then I'm going to go to my y-axis at 5. And I'm going to go up 1 and right 1. As large as it'll let me go. And I can go down and left. No more piecewise, so it's all the way across. By the way, y'all did really good on your tests. Just saying. I do have them. My poor 7th period, I don't have 7th period, I don't have to wait till Monday. I couldn't. Struggle was real getting 3 of them done last night. Oh no, it's a positive. Right. Thank you. Wrong way. It's not an I now yet. Alright, so we're going to add that 2x over. And we're going to divide everything by 2. Ooh, those are close. Okay, they're parallel lines. Before you even graphed it, you should know that they were parallel lines. What?
That's not parallel.
Not the x's, the slopes.
Parallel.
Yeah, the number in front is the 1. So the slopes are the same. The y-intercepts are different. That's how you know they're parallel. That is called inconsistent. Very good. And if it's just like when we did when it was not a function, we're done. We don't call it anything else. All right, let's flip to the next page. Sebastian, you waste your time when you talk about it. You called yourself out. I did not call you out. Okay. All right, here we go. So let's see. We're going to solve this one, and then I'm going to let you do one on your own. So you're going to subtract 3x. Then we're going to divide by 2. You got it, Diane? Now what do you want?
Sorry. Passing on his television.
Oh, okay. They forgot to hand them out.
Caitlin's.
Kaylin, she's back right there. You finished?
Yep.
Okay. See ya.
Wow.
So I got that for the first one? Hello?
Yeah.
Okay. Oh, you hadn't graphed it yet?
That's like mine longer.
I got those.
Oh, did you do it on number 4?
So if you have a negative with a negative,
Yeah.
cancel out.
They cancel out, make a positive, yep. You really technically, when you're graphing, you could leave it, because that would mean you would go down and left, which is the same as going up and right. It'd be on the, well, it's not the same, but it's on the same line. Alright, so I got x minus 2y equals 4. I'm going to subtract the x. But be careful, because when you subtract the x, that leaves you with a negative 2. And divide by negative 2. So that's positive 1/2 minus 2. This is where? 1, 2, 1. Nope, right there. Yeah, I don't normally give you one that crosses in the middle. Or at least I try not to.
Reading across the middle.
Like,
Not on a point.
it's on a decimal. This one's not, but I try not to give you one that's on a decimal. Alright, so what's this one called, guys?
Consistent.
Yeah.
Independent.
And independent. Very good. And so on the ACT, the main thing they're going to want is they're going to want that one solution point. So what is that? 4 and what? 4 and 0. Yep, there you go. Alright, y'all can try 4. Y'all try 4 real quick, okay? Y'all try 4. Alright, here we go. Did y'all do the same thing on this one? Don't you eat all those? But you say that. Some people don't. Are y'all okay? Any questions? You can it in case you need another one. So what do we call this one?
It's consistent dependent.
Very good.
I didn't know what.
Son, what are you doing this class? You're not in your kitchen.
I didn't know what.
I just want to give Bella a stick after she offered water, so I'll bring it to my son.
Thank you so much.
Well, thank you for being thoughtful, but
I care about my class.
I know that, and I'm glad. Oh my Jesus. Okay. Y'all. Especially. Alright, so we're moving to substitution. Come on, let's focus. We got stuff to do. We're moving to substitution, okay? So we no longer care. Come on, focus. Get it together. See what happens when you start laughing like that? Drink you some water. Don't swallow your cough drop. I thought you said you were better.
I did
No,
too.
in
Drink
his
some water,
sentence,
let's go,
saying
come on.
he was better than Tony.
You better?
I think there.
Okay. Alright, here we go. So when we do substitution, we don't care if y is by itself. Here's the note that you want to make for yourself, okay? Make yourself a note somewhere about substitution. You want a variable. Doesn't have to be y. It could be x. You want a variable by itself. So let's look at number 1. Do you see a variable by itself?
Next.
There you go. So if you go to the cashier and let's say you have, I don't know, $5. You have $5 and you want her to change out that $5 for something. What could she change that or he change that $5 out for? 5 ones or
20 quarters.
there you go, 20 quarters. You all okay?
Or 500 pennies.
So we can change out x, and instead of x, we can put what x equals. What does x equal? Now, do you see an x in the other equation that we could plug into?
Yes.
The 3x, right? Now you're going to ask yourself, okay, what the heck's the point of doing this? Patience, grasshopper. There you go.
It's so fun.
I hate them. Oh my.
Don't say the word hate.
I strongly.
If you hate this, you're really not going to like the Algebra 2 part.
Maybe not the people.
This is just Algebra 1.
What?
Alright, so is anybody lost about where I plug that in at? Why I plug that in? Okay, so right here it says 3 times x. But I don't want to put 3 times x. I want to put what x equals. X equals the 5y plus 3. Then the minus 2. Y. And then the equals negative 8. And the point of doing that is so now we have 2 y's that we can solve for. Okay, alright, here we go. So we're going to distribute. So negative 15y. Yep. Perfect. Now those y's are on the same side. So you're not going to do the opposite. You're going to say negative 15 minus 2. That gives you negative 17. Yep. And then you're going to subtract 9. No, not add 17. Divide. Very good. That's not your full answer though. Look back at number 3. Look back at number 3 that we graphed earlier.
Now we found y, so now we can plug y in into the other.
Very good. You remember that order pair that we found on number 3? That 4, 0 that we found? We've only found the y value. Now we got to plug it back in and find the x value. Here's the cool thing though. It doesn't matter which one you plug it into, but what's the easiest one? Very good. It doesn't matter, guys. You'll get the same answer. But this is the easiest one because most of you could plug that in and get your answer in your head. So you'd have -5 plus 3. Very good. So write your answer correctly. It's an order pair. So your x value is -2 and your y value is 1. That's your solution. Good job. Y'all okay? So if we were to graph those two, if I gave you the same equation, because on your test, I could give you one equation, and I could tell you to solve it by graphing, I could tell you to solve it by substitution, or I could tell you to solve it by elimination, which is our third learning target, okay? So if we were to graph this, what would happen at -2, 1?
It would be the point of
It's where they cross, Melody. Very good. So since they have a point where they cross, if I were to graph these, what would I call these two systems of equations?
Consistent and independent.
Beautiful. Consistent, independent. There you go. All right, what about number 2? When we have the word substitution, your directions told you to solve it by substitution. What do you have to look for? What do you have to have? Do we have that?
No.
Not yet, right?
With 0, it's a
No. That's when you find the intersection.
You said y from the substitution.
So you have to make it. Does it matter which variable I solve for?
No.
No. So which one do y'all want to do?
The bottom one.
Yeah, but with letter.
Y.
Yeah, let's do y since we did x in the other one, just so y'all can be well-rounded, okay? So if we subtracted x, that would be y equals -x minus 12. You could do the x. You get the same answer in the end, okay? So now, Kira, we're going to take what y equals right here, -x minus 12, okay? And we're going to plug that into this y value right here because it said y and y. We're going to match those up. All right, so we have 2x minus 3, but I'm not going to put y. I'm going to put what y equals, -x minus 12 equals 6. Are y'all okay? Looks like some of y'all are working. Y'all don't need me. Y'all got this. All right, and then we're going to add those x's together because they're right next to each other. We're going to subtract that 36 and get -30. We're going to divide by 5 and get -6. But don't circle it because it's not your answer.
Can you look at mine and see what I did? I tried to solve for y, and I got something crazy. Well, let's see.
Oh, because you did 2 times -12 was positive 24, and it's -24. That's all you did.
Okay.
All right, which one do y'all want to plug into? You want to plug into this one? Okay, you could have plugged into this one if you wanted to. It's the same thing, okay? All right, so we get y equals negative parentheses -6. You guys gotta be real careful, okay? So that's positive 6 minus 12, which is -6. So what's my order pair? So if I were to graph those, what would be happening at that point? Point of intersection, which means we would call that what if we were asked to? Beautiful. All right, let's go to the next one. Yeah, and if you're confused, you plug them back in, and they should equal that number on the end. Very good, Belle.
I mean, you went too fast. I didn't know what you.
-6, -6. Is that what you got?
I was trying to figure out x.
So that's like -1, and then times -6. Minus 4. Yep. And you should get -6. All right. So the direction said substitution, right?
Mm-hmm.
Okay. Substitution. So substitution means we need what?
A variable.
Doesn't matter which one, right? So if you don't like dealing with negatives, you deal with this top equation, okay? Doesn't matter. Which one do y'all want to do? You do the top one. I like that one because it doesn't have negatives. It just makes my life easier, okay? So what letter do y'all want to solve for? To solve for x? Okay. So you should have gotten 3x equals negative 9y plus 18, right? And then you divided and you got negative 3y plus 6. Yeah, that one looks a lot better. Alright, so you just got to be careful when you plug it in. What number is in front of that x that you're going to distribute? Hold on, Diane. Oh, let me. Okay, so what number is in front of x?
Negative sign.
Negative what number?
1.
1. That way you're going to distribute a negative 1, okay?
Oh, wait, so how should we do it?
I don't know, Sebastian.
Why don't you just plug it into line?
Oh no, you got to plug it into x. Alright, but that is a very, like Sebastian, it's a very common mistake though. So, alright, distribute the negative 1.
I forgot to say something.
Oh, you don't get 0. You get negative 6 equals negative 6. And back in chapter 1, it's all real numbers. And Melody, what would that graph look like?
Consistent.
Very good. So that would be the same line, which would be the consistent and dependent. Very good.
So on our test, would you want us to put all real numbers or consistent?
If it asked you just to solve, you would just put all real numbers. But if it asked you to describe what it looks like, then you would put consistent and dependent. All right, we're on number 4, because I want y'all to try number 4, but it's got A's and B's instead of X's and Y's. So how do you know which one's which? Beautiful. Alphabetical order. A would be X, and B would be Y. So y'all try that one real quick. Yes, Sebastian?
You didn't finish it, did
You don't have to, baby. It's all real numbers.
you? Oh, okay.
But there is no specific X or Y where they cross. They're all the same.
So this one's the
Same one. That's what we just did. All right, you try number 4, okay? You won't. Then we did something wrong. You sure? Oh, okay. All right, so did y'all solve for A?
We vote for B.
I saw for A.
I probably would do A.
I mean, yeah, I vote for A.
Yes. Oh, well, it'd help if y'all can see it, wouldn't it? I don't know why I just circled that. So, did y'all get 6 for B?
You got 7?
You got 7? Where did you get 7 from?
I put A, 4 divided by
Divided by 14 is definitely 6.
Okay, that's not good. What happened was,
So that's why you guys don't have to do math in your head.
I
You
put
don't have to worry about
12.
that. Oh.
Oh, that's my answer. Why did I just circle that?
What's wrong?
Yeah.
Are you sure? Positive? Are y'all okay?
What do you come to pay for the brackets or everything?
Brackets?
Yes, brackets are on numbers. Because that's what we would base on.
No, sir, we did not. No, sir, we did not. The only time we put brackets before was when we had closed circles. You haven't even graphed it, how do you know it's anything? It's an ordered pair.
Because I see numbers.
You're not finding domain range, you're putting it in an ordered pair.
I know.
Okay.
But my brain does it.
Yes, -4/6.
When did you work that part out?
Earlier? I've been doing this much longer than you do. I can do it much faster. Alright, let's look at elimination. Are y'all ready for the last one?
Yeah.
So our learning targets today were to solve by graphing. What was so special? How did you have to solve by graphing? Solve for y, right? And then solve by, I can solve systems of equations using substitution. How do we use substitution?
It's variable.
Any variable, right? As long as it's by itself. Alright, elimination. You ready to write your little note about elimination? Here we go. Ready? Alright, here we go. Elimination. You need the same number with the same variable. You need the same number with the same variable. Same number with the same variable. Now let Sebastian, let's lock himself out.
I say we leave it off.
No,
Just one day.
we can't do that, no. Let's go. We have 10 minutes. Let's go. Alright, so do we have the same number with the same variable?
No.
No. We've got 1 and -1 and 7 and 2, right? But that's okay. Because we can make it, you know? We can make it. Because you can do anything that you want to as long as you do it to everything, right? Consistently between everything.
Wait, do both variables have to be?
Just one variable, just one. So do you want to work with the m's or do you want to work with the n's?
7. Or
The 7 and the 1?
So multiply everything by 2.
Going to work with the 7 and the 1?
Yes.
Okay. Alright, so I need to make 1 become the same thing as 7. So what would I multiply 1 by?
7.
7. That's okay. As long as I do it to all of those terms in there. So the 7m minus 7n is equal to -63.
Is that our answer?
No, ma'am, it is not.
You have to subtract them over top of each other.
All right. Yes, ma'am, Bella. So now the word is eliminate, right? How do you eliminate, which means get rid of?
You stack them.
You stack them on top of each other, and we would do what?
Subtract.
Subtract. What's 7 minus 7?
0.
They cancel out, right? But here's where you have to be careful because subtraction is always where y'all go wrong, is right here. -7 minus 2. -9. Very good. Same thing. Be careful. -63 minus 9. How much is that? Very good. Dalton, yes, sir.
Wait, when you distributed the 7, you have 7. Oh, never mind. I see.
Are you sure? Okay. Yeah, we're not worried about the signs. You just multiply by the number.
It's just where you wrote the other question. I see.
Oh, okay. You just wrote it over here. And so we would divide, and what would we get as our n value? 8, right? All right, so then we have 3 different options to plug in. We have the original 2 and the new one where we multiplied. Doesn't matter which one you plug into, they'll all give you the same answer. Which one? The
first one.
first one? Okay. You can plug the bottom one in, you're gonna get the same answer.
But it's more work.
Yeah, you got some bigger numbers, so it'd be a little bit more work. Let's think smarter, not harder, as my daddy used to always tell me.
-1.
And you do indeed get -1. Which letter comes first in the alphabet?
M.
M. Yes, very good. I thought he said N for a second too.
Okay, real quick.
You better hurry.
So mention on her ABC, so Josh said A, B, C, D. Okay, fast forward. And she doesn't say it, she said elementary. She stopped and she said elementary.
That's funny. She can say it really fast.
Oh, she said elementary.
All right, let's look at number 2. So number 2, his little sister.
Oh.
His little sister.
I call my
His little sister. All right, number 2. It says elimination, right? So we have to use what the directions say to do. So how do you want to get the x's to be the same, or do you want to get the y's to be the same? I personally like the x's myself just because they would be smaller numbers, but you'll get the exact same answer if you do the y's, okay? So you have 2 and 3. What number does 2 and 3 both go into? 6. Very good. So how do I make 2 become 6? There you go. And how do I make 3 become 6? There you go. You just have to multiply, guys, everything. This is like when we were doing those fractions and y'all forgot to multiply everything to get rid of the fraction. Ooh. What happened? Everything does, right?
It's all real numbers.
So, no, it's not.
Oh my goodness.
So what would happen if we subtracted?
The X's would go.
The x's would, Bella. Very good. What would happen if we added?
The Y's would go.
The y's would go away, right? Which one do y'all want to do?
Subtract.
Let's add it.
Yeah, we already did subtract. Let's add on this one to mix it up a little bit. So we would have 6x plus 6x is 12. But then 12 plus negative 12. Beautiful, but we don't have to write the 0 because we already have the 12 there.
Equals 16 x equals 5.
Very good.
And then plug in the bottom.
Which one are you plugging in? The bottom one? Okay. So we see 3 times. You'll get the same answer, Bella. Yeah, I probably would too. Just 'cause I don't like dealing with negatives, but that's just me. It doesn't matter which one. You'll all get the same answer in the end if you did it right. Yep. All right. So what's our order pair?
5, 2,
5 and 2. Very good. So if we were to graph that, what would be happening at that point? They'd be crossing, which means we would call this one what if we were to graph it? And independent. There you go. Let's flip over. Come on, let's get some more of this done so y'all don't have so much homework. Well, to the next page. You know what I meant.
This isn't today, is it?
Oh yeah, we gotta catch up. That's why I haven't given y'all a calendar. Oh no. That's why I haven't given y'all a calendar yet, because I don't. Actually, we'll be one day caught up after the day. So, all right, here we go. Number 3. We're gonna do this one together, and the rest of them you're gonna do the homework. You wanna do x's? That's probably a good idea.
Yeah.
So let's see. We'd multiply that by 2. Yep.
Wouldn't it be negative?
The sign just determines if you add or subtract.
Oh, okay.
Yep. I don't like multiplying. Some people teach you to multiply with negatives. I don't like doing that because every time you add something else different in, you get one more chance that you could make a mistake. So that's just me personally. But if you do negative 2, Kira, you will get the exact same answer as we do. You'll just add where we subtract, or you'll subtract where we add. It'll just be a different sign. Okay?
Wait, what?
How do you know if you're adding or subtracting?
So whatever makes them go away. So 4 and negative 4. You subtract 4 minus negative 4, you get 8. If you add 4 plus negative 4, you get 0.
But the Y's go away too.
So it's all real numbers.
Is it undefined?
Which one do y'all want to do? Well, we have to add for either one. All right, so 4 plus negative 4 is 0. But negative 2 plus negative 2 is also 0, and we have to write the 0, guys, because there's nothing else on that side. Everything canceled, so you have to write the 0. Negative 8 plus 6 is negative 2. Those do not equal each other. So that is not our real numbers. That is no solution. So if we were to graph that, what kind of picture? Parallel lines. Very good. All right. So here's what's going to happen. We have 4 minutes left, and in those 4 minutes, I'm going to hand out your tests. And you could at least go ahead and get 1 problem done, if not 2 problems done. So, because 4, 5, 6, and 7 are your homework for tonight. But you can go ahead if you hustle and at least get 1 done. Sebastian.
Good job.
Alright, so how long do you have to do test corrections?
A week.
You have till next Friday.
What do they do?
They're supposed to be doing it today.
Bella.
But that's okay. I'm so happy. This time, but I'm so happy.
Let me pause this real quick. I hope that didn't spill on my floor.
It